Consider that deceptively simple form of packaging, the plastic water bottle. The water inside can only vary so much from brand to brand, so a staggering amount of money and manpower goes into the container. According to the National Resources Defense Council, at least 90% of the cost of bottled water covers things other than the water itself, including packaging, marketing, and shipping. Americans go through 50 billion bottles of water annually. And to design them, many of the beverage industry's major players turned to Amcor Rigid Plastics of Manchester, Michigan. On the surface, packaging a drink seems like a no-brainer. But designing the bottle is more complicated than you'd ever imagine. One reason why is they have to solve a vexing problem. And the answer, oddly enough, comes straight out of your vegetable garden. The problem is that plastic bottles can easily deform shortly after they're filled. A liquid entering a bottle during the bottling process has been heated to 185 degrees Fahrenheit for pasteurization. As it cools, it creates a low-pressure vacuum that causes the bottle to contract. Amcor's solution is hiding diaphragms in the walls and base that absorb the vacuum. The inspiration for the design? The inside of a bell pepper.
We're actually working with the vacuum. That vacuum itself is helping to form this new geometry. And because these are new technologies and a new way of looking at absorbing the vacuum, it naturally is giving us forms that we've not had before.
When the design is complete, engineers test it in a virtual world.
It's like crash testing a bottle in a computer. Everything that bottle is going to experience in the real world, like top load when it's being filled or stacked, and also the vacuum or perhaps even internal pressure like in a soda bottle, we're going to go ahead and test all of that in the computer.
Competition in the bottled beverage industry is fierce, and the look of the packaging can have a huge impact on consumer preferences. So graphic designers create virtual store shelves to show how the bottles will appear on display. Designers can also get a feel for how the bottle fits in your hand before it's ever made.
We can simulate how a real hand of a person is going to grab this bottle. We have hands we can move, fingers we can move. We can see where the contact points on the bottle versus the hand.
All of our products do have to function. That's the most important piece of it, is that it functions and serves that purpose to protect the product and stand up to all the conditions it'll go through from manufacturing to the store shelf and onto the consumer's home.
After the virtual bottle satisfies Amcor's packaging brain trust, a 3D printer churns out a prototype. The print head makes several hundred passes over a volume of plastic powder, and in each pass sprays a binding solution in the shape of one thin cross-section of the bottle. Layer by layer, a solid form takes shape. And after 3 hours, the prototype is complete. Next, digital scanners analyze the bottle's dimensions to confirm that it measures up to the design.
We'll do dimensional verifications to make sure that on the manufacturing side we've got what we need, and we'll finish polishing this model up and send it off to the customer for final aesthetic approval. Once we've got final approval on the aesthetics, we're off to making bottles.
And those bottles are made from a plastic called polyethylene terephthalate, also known as PET. Light, flexible, and durable, it was patented in 1973 and did for water what the pop-top can had done for soda. It turned water into a drink we could enjoy anywhere, anytime. But our devotion to bottled water comes at a high environmental price. PET is made from petroleum, and more than 17 million barrels of oil are required to produce the 30 billion bottles purchased by Americans every year. Since PET is non-biodegradable, environmentalists advocate aggressive recycling efforts.